Starting the recording. Here we go. So anything you say and or do will be captured now. Just be aware. Here we are. That's again, the challenge I gave you guys was to see if you could fill out the add debit card and create debit card methods this time. So debit cards. We know that debit cards are cards that are. Let's do the thing here where we do the. Okay, we're going to create the debit card here. So if I do, again, the nice little way of following through this is do debit card, new card equals new debit card. This is now I can know what do I need? What do I need to get in order to create this? So I need a card number, which we can generate, right? That is a number we can generate. I need a PIN number, which again, we can generate. I need a security code, which again, we can generate. I need a card owner, and I need a checking account primary. So those are two things I need to get from external system that I can't generate is the card owner and our checking account that we want to connect to. So those are the two things we can't really automate. We can't generate. As for the first three, now, theoretically, we could use our chaos system to generate these numbers, but really that's going to generate a actual number, not really a string of numbers or an amount of numbers. We want a certain number of numbers, right? Our credit card number, for example, like most debit card numbers have how many numbers on them?
12.
Yeah, 12 numbers, right? 4 times 4, right? Yeah. No, right? Yeah. 4 times 4. Yep. That's 16, I think. Yeah.
16.
I was like, wait, 12 sounded small, but maybe it's American Express. I don't remember. I know one of them has a shorter number. We know PIN numbers on average have 4, and our CVV numbers or our security codes on the back are usually 3 numbers, maybe 4 numbers. So those we want to generate more like a string of given numbers. So let's create one final tool for ourselves. We're going to call it a generator tool. So this thing's not an interface of any kind. This is just a generator tool. So we're going to create a Java class called generator. It's going to have a system that can generate multiple things. All right. And this one we're going to use, again, we're going to use random though. Random rand. Random. This one, we're going to do a public string random code, we'll call it. We're going to call it random code. What this is going to take is this is going to take a string of characters and an int of length. Right? How many items? So we want a string of characters and a length of them. So all the characters we want to have and then the length. We want to be able to, let's say 4 times, or in our credit card system, 16 times we want to pull a character from this string. And so we can give it a string of numbers, right? 0 through 9. You can give it a string of the numbers 0 through 9. And 16 times we want to pull a random item out of this. Well, how can I use this though in a way that's easier to pull from? I want to make this something that I can easily pull data out of. What can I use for that?
You could parse it.
I could parse it, but I could also, what's a nice collection that allows us to access items via a positioning system?
An array or a list?
Yeah, I could just do I can do a string array chars equals characters dot split, right?
Split. Yeah.
And turn whatever string I get, whatever string I get, I can just split it into an array of as many characters as I want.
Right.
And now I can do, I got to do that. Oh no, not yet. String output blank. And now I'm going to do 4. Oop. And then just jumped in. Nice. 4. Count 0. And this is one of those big things that I like to do. If there's no real given variable, try to use count over I. Again, this is just trying to break that image of a student, because students commonly use I. We commonly use I and J. So this is why I like using count. It just kind of disconnects it from that student feeling of always using I in your for loops. Once you have the job and you see that the people there use I, go ahead and go back to it. That's fine. But in the interview, you're always, one of the things you're really trying to do in the interview is disconnect yourself from looking like a student and looking like a developer. You want to make sure they feel, okay, I'm working with a developer here. I'm working with someone that's developed stuff, not just classwork, actual things. So that's why I try to impose on you guys to stop using I and J and use very good variable names, because it disconnects you from looking like one of those students or someone that just came out of a classroom. Because again, we're constantly taught in for loops to use I and J because they're simple and easy to just kind of get through them. So you can really use them quickly. There's Joel too. Nice. Lynn and Joel both at the same time. Nice. Welcome, welcome. So count equals 0. Count less than length. How many we want? Count plus plus. All we're going to do here is do output plus equal chars ran dot next int, with our bound being chars dot length. That's up to but not including. That's 0 and up to but not including. That's going to give us an integer. So that's going to give us one of our indexes between 0 and up to but not including the length. So that'll give us an integer of the cars array. Exactly what we want. And all we got to do next is return output. What I also want to do here is actually mark this as static. Why is this not allowing me to do static? Can I not do static then? No. Right. Yeah, there we go. The reason why I want to do this is because now I don't have to instantiate a generator. By making these both static, generator is now a static class. And what that means is that static classes don't have any randomization. There's no different instances. Like we've talked about how, I don't have cups with me right now, so we'll go ahead and use pens. I have 2 pens, right? We can look at my video for a second. Hopefully you can see me. So I have 2 pens. Let me actually stop sharing the screen for a second. We'll do that. That way you can see me, and we'll make you bigger. Speaker, me, or you know, pin me. At least on the video. So I have 2 pens, and they're exactly the same visually, right? These are the same pen, just 2 different ones. But I do have, I'm instantiating this one. This pen is a different instance of the pen, where this pen is its other instance. As I use this pen's ink goes down, but this pen's ink doesn't, right? That's why these are still instantiated. They can have varying values of ink, and even technically, even though they look the same, one could have black ink and one could have blue ink, right? One could have red ink. And so even though these are the exact same looking pen, they are still instantiated and have their own personal stats and attributes that don't affect each other. That's why we have instantiation. Static items are these items that are the same no matter what we do. So the let's say, for example, what in the real world is there only one of? And like, it's hard to say, like this one's hard to really represent in the real world per se with a physical object, because everything has an instantiation. You always make copies of it. But like the concept of time is not something that is instantiated. My time and your time is the same. When I say it's for everyone in Rhode Island, I guess, 1 o'clock is 1 o'clock for everybody. We all share the same instance of time. When time passes for me, time passes for Evan, right? Yep. When 3 minutes passes for me, Evan's time also passed by 3 minutes, right? So we're sharing the same instance of time. That's a little weird to comprehend. It's starting to get into philosophical conversations, but that's kind of the idea here. There's one instance of time that we all share. We're all living in the same time period. We may experience it differently. We may see a different time on our clock. We're all experiencing the same instance of time. We're all in the same instance of the present time.
Like, what happens if you and I are walking down the street at the same time?
Yeah. I guess that's maybe helps a little better, but again, this is what the static concept in the real world is a little harder to get, because you're really dealing with items that don't physically exist. Can I share my screen? Why is I don't have the green border? That looked weird. Let's do that again. Make sure we're good.
The only other way of explaining this in code wise is static. If you have a static class or like in such a way, you could use it anywhere. It doesn't really care where it's located. It's static, so it knows it's an available item to use. You don't have to make a new one to be able to use it.
Mm-hmm. Yep, exactly. you're not creating this item, you're not instantiating, you're not bringing it into existence, and you don't have multiple variations of it that can be different between each other. Each generator is exactly the same. That's kind of the idea here. So we create a generator class, we go back to bank now, we can use our generator class to generate those items. So let's see how that works. So first, by not actually doing that yet. Hold on. Let's test this generator class in our main class. So I'm going to comment these out because I might want to use them again. Let's test out the generator class. So s out, generator dot random code. I'm going to give it the string A, B, C, D, E, F. I'm going to give it a length of 5. So I want to do a length of 5, and that'll be it. Yeah, good. Let's do this a couple times. Let's see what this gives us. Take a look. We get 5 random strings that contain the letters between A, B, C, D, and F. We can see we have D, so there's A here, B, B, C, we have D, E, F's up here. Well, that one actually had a unique character, each and every one. We didn't have any repeats in that one. Nice. But that's kind of what the idea here is. And you can see how we didn't have to do generator equals new generator, right? We were just able to straight up use the generator class and use the random code method without having to instantiate a generator. That's the benefit of a static class. So I do want to kind of quickly throw that in there to make sure everyone understands static classes, because that is something you might get asked. Question, Will? Oh, no. Okay. I see your mouth moving. I'm not sure if you're asking a question. Okay, cool. Just
so can you repeat that last part again, Will?
Sure. So again, what we did here was we created the generator class, which is static. Because we made it a static class, in our main, we were able to use it. I'll pull this down a bit. We were able to use the generator random code method without having to instantiate generator. We didn't have to do generator gen equals new generator. We didn't have to do this in order to use the random code method, did we? Because it's a static method, we can just use it straight up. We don't have to instantiate. We can just use the method directly from the class. So that's what a static class can do. And we do that because, again, if we look at the generator class, there's really nothing unique about one generator versus another generator, is there? They're pretty much the same thing whenever we use it. It's just a class with a random method in it, with a random field. We could even, if we really wanted to, we could also just take this method, this item here, and just shove it inside the generator, honestly. It doesn't need to be outside the class, or sorry, outside the method. And now there's nothing different between any two generators. Like we said before, like we were saying with our example, we all share the same time. When 3 minutes passes for me, 3 minutes pass for you too, right? If I say, hey, I'll talk to you in 30 minutes, I wait 30 minutes and you wait 30 minutes, right? We're sharing the same instance of time. I may experience it different. I may go into my code and suddenly 30 minutes goes by really, really fast for me, where you might be sitting there staring at the clock and it feels like 30 minutes took forever, right? So we can experience time differently, but we're all sharing the same time. We're all sharing the same instance of time. We can all know that when 30 minutes pass, 30 minutes pass for everybody. And that's kind of this idea here. We're all sharing one generator. There's not two similar pens that are different though. That's why we're here. We will just do generator of the class, not an instance. See the capital G. We use the class definition and use the method directly. We didn't have to use this in order to get access to that method. That's the difference between a standard class and a static class. So that's I just want to make sure we did touch base on what a static class looked like. So I wanted to add a static class to your system.
It's a really good thing to have, but it's so powerful enough that you don't want to use it everywhere, because you can technically use it everywhere, but you won't be up to code for all sorts of people accessing things that they shouldn't be accessing or changing things around. So
potentially, but also in the same code, and that
but
just again
good for like a static thing like a generator or an input system like a UI where you can't change anything. It's just there because it's for usage only. You're not doing anything to that particular class.
Well, mainly what it is that they're useful for tools, for things that just do actions. They're not really saving state. They don't have any sort of unique attributes that you have to keep track of as they go. So we don't need to keep track of anything in the generator. So that's why it's perfect as a static class.
And like the UI as well, technically like a UI type, not interface, but just like a UI, like input systems, you're not changing anything. This
That
is
would
an
be a
interface.
challenge to
No,
see if
this is
you
like
could.
this is like an interface, but I'm just saying if you made a like an input class, you can make that static, where it's just accepting input only, and you're just using that.
Hold on, Jim.
Yeah.
What I was going to say though is that there's a challenge here that you probably could, and I'm going to say I would probably recommend this, that the interface, our UI interface, as well as our console and chaos classes could be converted to static versions of them.
Oh, okay.
So you can have an interface that is a static interface, and the classes that are implementing them can be static as well.
Okay.
So you can have static interfaces and static implementers.
But yeah, those are the kind of things, like that kind of stuff you would want, like kind of static more than just like private.
I didn't want to do too many things in my interface, so I didn't want to do an interface and a static interface at the same time. So I didn't do it, but just be aware that if you wanted to, that's a good extra little additional challenge you can do to yourself. Can I convert our UI, console, and chaos classes to be static items so that I don't have to instantiate one? I can just send it over.
Yeah.
So the difference here would just be, we would just send it over instead of having to instantiate it. So anyway, something to think about. But that's it. I want to make sure the main focus of this, like I said, I could have put this technically like inside our console classes, but I wanted to create a separate static class that there was an example of a static class in our bank system. So you see what a static class is. So you can make sure that at some time you do understand that they exist, and an example of one. So just be aware that this is what that is. This is an example of a static class and something you could create in other systems. So with this, we can definitely use this method here to generate a card number, a pin number, a starting pin number for our users as a security pin, and our CVV. So if we head back to our bank class, let's go ahead and do, okay, well, I need a card number. So let's do string card num. We'll do generator. And this is the other benefit of using the static classes. Again, I don't need to instantiate, and I don't need to send anything through the actual method to get this class to work. Again, I can just use it, generator.random code. And what I want to do is I want to send, what characters do I want to use for my credit card?
Numbers.
I want to use all the numbers, right?
Yeah.
So I could do this, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But it's likely I might want to use those again, huh? So one thing I can do that is actually really good is I can make, again, what's called a static variable, or sorry, a final variable. I want to create a constant. So up at the top here, I'm going to bring in, I'm just going to do private string numbers. And again, we use all caps to denote that this is a constant item, that this is unchangeable. And to really sink that in, I'm also going to add in the word final here. What does final do?
Final makes that variable a static value, so it can't be changed.
As soon as it's set, as soon as it has some sort of value, it can no longer be changed. That value is, as you would say, final. So that's why they use the term final. Whenever you set it to whatever value it is, once that value is set, that value is the final value of the variable, and it can no longer be converted. The reason why I word it that way instead of just saying it's constant is because you can actually make a variable from a parent class final in a child class, and that child class then says from this point forward, any child classes here can no longer change this variable. So you can have a variable in a normal class, in a parent class, be non-final, have a child class, declare that variable as final, give it a value, and now no longer can that item be changed. Kind of cool. So definitely something to look into. There's some really good use cases of the final system. But the key thing, the basics, like TLDR of it, the basic use case is just, it makes a variable constant as soon as you set the value. So I want to show something quick here. I thought I didn't have to initialize it right away. Whatever. I know there's a way that you can make something final without initializing it immediately, but I'll look into that later. I'll double check that syntax. I know there's a way to do it. Anyway.
You could just declare in the beginning, right? Like you just.
Not worried about it right now. Focusing on the other stuff. So we got that random code. So now we can just send numbers over. And how long is our credit card? You said
16,
12 digits. Or 16.
12.
16. It's 16.
Well, again, it's our bank. We could always make our cards 12 if we want. So technically not wrong. It's just, yeah, we're just it's deciding what do we want our card numbers to be. We could even be weird about it and be like, you know what, we have 7, our card numbers are 15. So we can also be like, you know what, our card numbers are 21. We have 21 numbers in our cards. I feel like it's a little evil to have to make people type 21 numbers, but we could do that. All right, so we have that. We can also do string pin is generator dot random code numbers, and we'll have a code a pin of 4. Last but not least, string security code generator dot random code numbers and 3. So we definitely needed those 3 things. We needed our card number, a pin, and a security code. If we uncomment this for a second and take a look, we know we needed Command P. We can put that in. Card num, pin, security code, and then we need the card owner and the checking account primary. So how do we get the owner? Do you remember how we did that before? How do we get the owner? If you have this code, try scrolling up a bit. I think we've done that in the previous method. How do we get the owner? So it can be helpful to code along with me. That way you can scroll up instead of having to wait for me to do it, because I'm going to wait. So if you have this code,
Isn't it?
what's that? Yeah, our clients are in a hash map. Yes, our clients are in a hash map. So what can we use to find our owner?
Yes.
Scroll up. We have our add account and create account. How did we find our owner? Because I know our account system, we need an owner for that. To create an account, we need an owner as well.
Return savings. You got the owner there. You got the owner there. But you got client. Well, add account. You got client or get the owner ID up there on line 57.
Look at here, right?
Yeah.
Over here, we pulled the client, but what did we, so have you stay quiet now, Jim? Someone else, like, what did we use to get the client? What here did we need in order to make this work? It's not a trick question. Yeah, client ID, right? Or owner ID.
Owner ID.
So
yeah.
owner ID, which is the ID of the client, right? If we know our client system, that's the client ID. And so we could just do the same thing here in our debit card system, right? We can grab the owner ID, we can ask for the owner ID and pull the client via that. So we can do the exact same thing. We'll copy that, paste that here, and note how that's yelling at us. So we definitely want to bring that over here and set that up. Alrighty. There's one item we now needed here. We did that in the add account. So I'm going to do that in the add debit card. And for debit card, we're just going to accept that now. String owner. We'll add that here. Last item we needed is the checking account primary. Well, let's take a look at how we did that before. So this is not our first debit card creating system, right? This is not the first way we've created and added a debit card to a client. We've done that before. Where did we do that before? Someone who hasn't spoken yet. Jim and Emilio, Jim and Evan, stay out of this one. Someone else.
Actually, I just kind of lost your train. I was trying to load up this project, so.
All good. Yeah, this is not the first time we've created a debit card. Where did we create the debit card before? I'm not asking what we did. I'm just asking where did we do this before? What method? What class?
Don't we have a debit card class?
We do have a debit card class. We have an add account method here. We added the account, but that's not where we created the card. In what class did we create a debit card and add it to a client? All your classes are right here. So take a look, and you can even, if you have the project, click through and see if you can find it. If you're not confident. think about it. Where else would we want to add a debit card?
I would want to put it in the checking account.
That definitely is a valid guess, but unfortunately, no, we don't do that hit there. We do link a checking account to our debit card, but we can have a checking account without a card. We can definitely have a checking account that doesn't have a card. So who else might be in charge of wanting a debit card? Or what other object? What other entity?
All right, I'm guessing to a bank account.
Good guess. Makes sense, but unfortunately, no.
Is that where it
That's
is?
another one.
It's a client.
A client has debit cards, right?
Oh,
There it is. Add debit card right there, right? We have an add debit card method where we get the account number and then we pull the account num in order to get that. So in this method, we can see we actually ask for an account num, so we can pull it from our account system, which if we scroll up is a hash map. Let's pop back over to our bank and see if we have any problems with this. Do you see any problems?
What's the,
Okay, if we go back to client,
yeah,
where'd that go? There it is. Our accounts on their client were stored as a hash map
okay,
because we
yeah,
want to be able to use the get method to get it based on our account number so we can jump right to it, right?
right.
That's how hash maps work. If we look at our bank class, are there any problems here? Or are we good?
I think we're good because we have the hash map of the clients here as well.
We have a hash map of clients. That's not what I
Accounts is a
mentioned.
list.
Oh,
But our accounts are a list. So we can't jump to our client via the ID number, can we? We'd
Oh,
have to
no.
loop through our account list to find the account we wanted based on the account number, wouldn't we? Not that efficient, is it?
Yeah, that's tedious.
Yeah, we don't want to have to loop through our account list, do we? Especially if we're a good bank, we're going to have thousands of accounts, right?
Yeah.
At least we hope so. If we're a good bank, we're a good bank. We're hoping to have thousands of bank accounts, right?
or hundreds of thousands of bank
Ex-
accounts.
I like that. I like that hopefulness there. I like that. Exactly. So let's go ahead and switch that up now. Let's switch this up. Let's bring it back again. So we'll see again, how do we switch our code that's currently using list system to a hash map system? So we're going to do hash map again. Let's double check the account system to see how our IDs are stored. So we go back to our account, bank account. We know that the account num is a string. So unlike our clients, our account nums are strings. So we do want to change that. So we're going to use string, comma, account. We'll do accounts, new hash map. That. I'm going to comment this one out so that we no longer have that clash between these two. And now we should see somewhere on this line here something red. We see those reds? One of them is our current, and this was a really nice feature of IntelliJ. If you hover over this, you can actually see what you're looking at and see where it's saying, what's kind of happening here. You see the warnings, the yellows and the reds. You see the red here is our debit card doesn't have all the parameters yet. That's fine. But if we scroll up to this other red, we can see we have the accounts.add. So we need to update that. So click. Accounts.add is our list method, and hash map is accounts.put. And our key is going to be new account dot get account num, comma new account. Sound good? See how that works? How are we getting the account num? Well, we click the account here. We do balance, get name, account type, UI. Where does the account num come from? Do we actually enter it or something? Like, where does this account come into play? This new account number. How do we get the account number? Let's pop over to our bank account class again and see how we get that. Balance owner account num type. So the third item is our account number. All right, let's go back to bank now and see what that does. Here it is. Integer to string, accounts.size plus 1. That still look good? Do we like this method, a way of getting our number of accounts? Or do we remember something from yesterday about this?
Ooh, that looks problematic.
Yeah, that was problematic.
Before you guys say it, I know you two are doing well today. Does anyone else remember why this was bad using this system on lists? We talked about this yesterday with our client system. With the clients list, we used it and then we changed it to do a counter. We currently have a clients counter. Remember? Does anyone from yesterday, other than Evan and Jim, remember why we didn't want to use this? Anyone remember the reasoning behind it?
Oh, I remember it. If you don't start with like 0 to 10, if you start with 5 to 10, you're not going to have the right math. It's gonna not resolve correctly.
True. And that's true. And how we could get that again, if you think about it, if we add, let's say Christian comes in and he adds a bank account. So he has account number account number 1. Then Emilio comes in and he creates a bank account. His account number is account number 2. Joel comes in, he creates an account. He's not account number 3 because we still have these 3 accounts now. So now we have 3 accounts. Now let's say Emilio's like, you know what? I'm not liking this. I'm not sticking with this bank. I'm going to switch. I'm going to close my account. So we delete his account from our system, from our list, from our hash map. Sorry, from my hash map. Christian's still bank account 1 and Joel is still bank account 3. Now Chang comes in and he creates an account. And that's account number, what account number is he going to get?
4.
All right, he's going to get, we want him to have 4, right? But
Yeah.
based on this, what account number is he going to get?
2.
Not 2.
1, 2. Wait, 1, 2. It's gonna get an account number 3. Oh, wait.
Yes, he will get account number 3 because Emilio deleted his account. So we only have 2 accounts now. Even though Joel's account is number 3, we only have 2 accounts. So when Chang comes in, our system is going to calculate that his account number should be 3, which then means we will then overwrite Joel's account and Joel's going to lose all his money. And he's going to be, how do you think Joel's going to feel about our bank account? How would you feel about our bank account, Joel?
It's gonna sue.
What do you think? Not too happy?
Yeah.
Yeah, we just deleted. We just had Chang overwrite your account, and all your account is gone. That would not be a good day for you, would it?
No, not at all.
And so this is why, yes, on especially on hash maps and systems where you're storing it, you don't want to just use the size plus 1. You want to have a counter so you can track. The only way we could protect against this, and I do want to at least make sure that this is aware because this is a thing that does happen and something you do want to be aware of when you both create accounts on websites and then supposedly delete accounts. There is a concept known as what's called soft deletion. And so soft deletion is this concept where instead of actually removing something, you just mark it as not active. So you mark it as deleted or closed. That way it still exists in the data. You still have that data, but it's considered deleted or non-active. So it can be hidden in certain situations. It's not grabbed in most situations. A lot of sites, especially like Facebook and things like that, use this system. When you tell Facebook to delete your account, unless you actually request the data and tell them to actually remove it from their system, they do what's called a soft deletion. They just flag it as deleted, but yet still maintain the data and still track you on their other systems because Facebook's APIs and Facebook's tools are used on a ton of other sites. So note that you are still being monitored and still being tracked, even if your account is not active. Even if you didn't create a Facebook account, you have an account with them. So those are things you want to be clear of in systems. If we would use that type of system, where if Emilio decided, I don't want an account anymore, instead of deleting it from the list and removing it, we just marked it as inactive or marked it as closed, then Chang coming in would be fine. He would get an account number of 4 because our size would still be correct. So there is a way that you could use this, but it is not a good practice to use this system, just to clarify that. But like I said, it's good to know that there are ways around that issue. So yesterday I showed you that this is an issue and we do have a workaround for that, meaning to fix it, where we do allow hard deletion. But then there is the idea of being able to still use this code if we want to by just enacting a system known as soft deletion. And it's just good to know that that's the same thing. There, we have that. Let's go ahead and add in our private int count that 0. And same thing here. Plus plus count plus count. That'll give us an accurate account number. There we go. That works there. Any other references to accounts? Let's take a look. Make sure we're good. So if we do a command F or control F, we can make sure that all of our other accounts have been updated. We have no bugs. I think we're good. I think we can go with that. So let's go
Bank
down
is
here
kind
now.
of, why is bank highlighted? It's in red under bank in your classes.
Where? This thing?
Yeah.
Here? Because we're currently working on it and we
Oh,
still
okay.
have,
Okay. All right.
this line's still broken.
Yeah.
technically.
Okay.
So now we have ability. Now we can, of course, now that we've switched our account system to a hash map, we can now search our account system if we have the account number. So we can now do account equals get account ID, which means we need to accept that. So string account ID, an account. All right, so now we can make sure we accept that. So let's go ahead and accept an account. And we will give that over. There we go. Well, maybe not. It's yelling at me. Why is that? Again, I want to hear some new voices.
I don't know, actually.
Oh, I didn't think to look at it. Christian, I'm sorry, I've been ignoring your chats again. I have the chat window open now, so now if you do give an answer, I'll see it.
Is
All
because
right,
it's
so-
a bank account? Is it a bank account that has to be?
Not not a bank account. It's a take a look at the pop-up. You're on the right path though. Again, I want to hear some more voices that I haven't heard.
Checking account?
We need a checking account, right? We require a checking account, but we have an account. So how do we change that? Well, I could try this. Okay, well, let's, instead of getting an account, let's do, okay, well, we need a checking account. Let's do that. Why is this yelling at me? What is accounts? Our accounts is a hash map that contains what? Right, it's a hash map that contains accounts. So we can't do it like that. So we can't do it like this alone. So there's actually two ways we could fix this. There's two ways we could do this. Any ideas? First, if I want to do this, account, typecast. Thank you, Christian. Yeah, Christian said typecast. But what I want to do this time is actually showcase that idea of checking for typecast this time. Because now we're on the bank. So what we want to do first is make sure that our account that we're pulling, that was given to us, is actually a checking account. That is one that we want. So we need to use instance of. If, account, instance of, checking account. Okay, undo. I don't know why there. There we go. Or not. We're going to actually do this instead. We're going to say if not account instance of checking account. We're going to do an S out error account primary account must be a checking account. And then we will return and do nothing. We're not going to do anything. We're just going to return. Otherwise, if we hit line 99, then we know that this was considered true, and we can assume that our account is a checking account. And so we can now go ahead and do debit card, new card equals create debit card client.getName, comma, checking account, do it like this. Account. Let's actually update this now to checking account. There we go. It was yelling at me. Oh, right. This create debit card is going to actually return the debit card. So let's go ahead and do return. There we go. So far, so good. So what we did here is we checked to see, to make sure that that checking account we pulled is an instance of a checking account. We want to make sure that what checking account we pulled from our accounts list, because it could be a savings account, it could be an investment account, it could be a CD investment account, it could be any of these accounts here, any one of these four. It could technically be a bank account right now because we're still using an interface. It could be any one of these five. And so that's dangerous. If we try to then typecast that when it's not actually that, we're going to get an exception error.
Why is
an exception error, we're going to crash. What?
Why is line 100 an empty return?
It was just there to make sure that this thing was happy. It was just there. It doesn't have to be there.
Oh.
That's why it's highlighted in yellow. It's telling me it's unnecessary.
Oh, okay.
See? Yeah, that's why it's highlighted yellow.
Oh, it's a void. Oh, okay. That's a void. That's why. All right.
Yeah. I had it there originally when we had a method that had no content, just to show it wasn't doing anything.
Yeah.
Otherwise, it yells at you for being an empty method. So anyway, unimportant. What was I saying? Crap, I lost my train of thought. Right. Okay. Yeah. Because the account that we pull based on the account ID could be any one of these five. If we try to typecast right here, do this line here, where we try to change our account to a checking account, and it isn't a checking account, that throws an exception error, and that will crash our program. That's a problem, right? We want to avoid at all costs crashing the program. We always want our program to constantly run until it finishes its task. If we hit an error, we want to catch that error or make sure that we don't crash, we handle it and make sure that the program can still continue until we hit the end of the system. And so this system of instance of is a very powerful tool for checking to see if it's one of those special types. You can use one of those special methods, either a special method or assign it where it needs to be more specific. Since our debit card requires a specific debit card, a specific account, we use the instance of system to make sure we're typecasting without causing an error. Make sure you know about instance of. It's a very useful item. After we create the debit card, what do we need to do with it? So we've created the debit card. Are we done?
I think we have to hook it to the account, don't we?
Yeah. Well, probably, because yeah, we've done this method, but this method, we really haven't finished what its task is. Its task was to add the debit card. So yeah, we had it call a create system, so it was created, but we still haven't actually added it. So let's go ahead and do client, add debit card. And again, we want to use our new overloaded method where the client isn't creating the card. We're just going to give it the card now this time. New card. All right, let's go back to main and see if this works. So far, so good. See what's happening. Adding it to the list. That's good. So we're going to go back to main now. I'm going to get rid of this test code now and bring back in this stuff. Let's do our bank dot add debit card. With command P, we know we're going to start by giving it to Jim first. So we'll go ahead and do owner ID 1 because we know that's Jim. And we're going to give him checking account 01 because that's our first account here. First account is a checking account. We're going to give it that one. And that's going to be a string. Just remember. There we go. We're going to then display the clients again. Well, actually, no, let's just do that. Hit play. Let's see if that gives Jim a debit card. Oh, right. Let's not go through it line by line. Let's switch this back to chaos so I can just go quick because I don't need to test that system out. So we'll switch back to chaos so that we auto-generate the daily limits and the savings account so I don't have to enter that 4 times. I want to save some effort. So I'm going to switch it to chaos because I'm not testing these lines anymore. I want to test this system. Oh, no, sorry, this system. So I'm going to switch it back to chaos so I can skip all these questions. And that's really the benefit for us on the chaos system, is allowing us to skip these inputs for us. Play. All right. Huh, not showing. That's odd. Let's put the show. Just client, there it is. Yeah. Card, debit, and debit cards. Back up. Add. We got no crash, no error messages. Oh, I'm done. I looked at the lanes debit cards. We want to pull this back up. There's Jim's card. Jim does have a card. What I am going to do though is I'm going to update the card.details method because I want it to actually display the card number, PIN number, and security code. So let's head over to our debit card method, our debit card class. Here are details.
My PIN number. Everybody's got to take my money.
But you got to show it to you at the beginning so you know to change it. /T card number plus card number, just num. Yep, card number. Yeah, we can just do the security code. We don't need to do the PIN actually. As long as those two work, we're fine. /T CVV security code plus security code. So yeah, we'll just print those for now, just so we can see it, and then we'll do plus /n. I believe we did that on the accounts ones too. So, oh no, that's already there. Cool. So I don't need to do that. Play. Let's see. There it is. Card number and a CVV. Let's give a lane card and see. Make sure that they get a different card number and a different CVV. Just make sure that works. So back to main. Bank. Add debit card. Our owner ID is going to be 2, and our account number. Well, take a look here. What account number are we giving the debit card?
The next one up.
So would that be 2?
Account number.
4.
No, it'll be 4.
Good. Give me 4. I'm going to do the number 2 first to make sure we get our error message. Remember, we actually we have a system there to say, hey, if it's not a checking account, let's crash it. So, actually, let me give it. I do want to make sure it's a lanes at least first. So hold on. Let's do that at least. We don't have a system checking to make sure that the debit card owner is the owner of the account number. So we don't have a validator for that. So do be aware that I could technically give a lane a debit card for Jim's account.
Yeah.
Elaine's like, go for it.
Yeah, go for it.
Oh yeah, treat yourself. Oh.
So you run that. If we scroll up, we can see error primary account must be a checking account. So we do get that message. We tried to give it a savings account for the debit card, and it tells us no, you cannot do that. Let's switch back to 4 now. Play. We should see we have 2 numbers or 2 cards now, each with its own different number. So we got 12 there, 12 there. We got 3 and 3. We got different card numbers. Look good. All right, so what you got in this one again? What you saw in this one, so the key items in this one again, just to talk about it again, we created a static class known as generator. So we now can generate some numbers based on a string, generate some code. So this is a great way to generate things that you need. And this can also be used for hacker things. So if you're trying to do a practice algorithm and you need to generate some test cases, you can always use a generator to do that. But static classes was key here. And again, just seeing again, how do we switch from a list to a hash map, especially because hash maps have this really nice ability to just grab something based on a set data type or set item. Why is this highlighted with green? What does green mean? All right, I don't know. Oh, that's open still. Yeah, get rid of that. Yeah. My Control F was still active. Yeah. So we got that. Good there. There we go. Close it. Awesome. We talked about instance of, so we can make sure that when we are doing the typecasting, when we need a specific type of an interface or even an abstract class, we can do instance of to make sure that that instance of that abstract class or interface is of the type we want before we typecast to make sure we don't crash. What I do want to show you now is to show that system though. If I comment this out, go back to main, switch this back to 3. So we're going to try to put a savings account. We're going to try to typecast a savings account as a checking account. So we're not checking to see, so we're not going to get an error message, but look what ends up happening. And this is why that instance of is important. We get an exception and we crash. Our entire program ends. All this work we did above this line is all killed. We don't get any of this stuff works. The entire program crashes. So that is why doing an instance of check before you typecast, if there's a chance that you might get something that isn't a checking account, is important.
It does tell you down there though, it says cannot be casted in a class checking account.
Yep. No, it tells you exactly what would happen. Yeah. It tells you
It kind
exactly
of
what
tells you
happened.
exactly why or what you
Yeah.
kind of need to do or understand kind of what direction you should go.
Yep. So that's important there. What I want to clarify is, yes, we did not technically do that here in our debit card class. In our client class. Know how I did, I said that we should do it. Again, I always want to point out that in the beginning, when you're first testing things, when you're first creating your code, don't worry about validation first because you're the one putting stuff in, you're the developer, you know what can and can't be in there, you're always going to put in safe items. And so in the beginning, making sure that you write code that works is way more important than validating right away. You can get lost in the weeds of trying to validate every single thing a user can do to screw you up, that you never get the functionality working off the basis. And what can happen sometimes when you put in all this validation, it can be hard to confirm, is it the validation that's not working or is the logic bad? And so what can be benefit, what's a good rule of thumb is to first go through the system, assuming you're going to get the perfect data every single time. By doing this, you're going to get the logic that's going to work with the right data. By doing that, by approaching the problem that you're always going to get the data you want, that you're always going to get the correct information, you're going to create good code that's going to work with the correct data. Once that stuff works, now you can add in the safety mechanisms, the catch-alls, the validators, the systems that are going to make sure that if something does sneak its way through, that something bad gets in, you can catch it and protect the system. That way, if something starts breaking, that way, in the end, after you add your validators, if what should work doesn't work, you know it's the validators that are causing the problem. You already know that your code works with correct data because before the validators, that code worked. So it's definitely something that the validators are causing your problem. So you know where the problem's existing. If you do the validators and the code at the same time, it could be either item that isn't working. 100% be okay with doing the code without any sort of validation, assuming you can get the good data first. After that works, then become the evil user and think, how can I break this and put in all your systems to protect the system? That's why we added it here. Didn't make a big deal adding it here first. I wanted to showcase how to use the hash map here. It wasn't really about the validation yet. But now that we've done this once before, we can now add in that extra task of confirming that the data type is what we want. Sound good? All right. That is our system. We have everything we need now to pretty much run our bank. We can create clients, we can create debit cards, we can create accounts, we can add debit cards to those accounts. The only other things you can do, of course, is add in the other pieces here to add in the other 2 types, and I'm going to leave that for you guys. That's an item you can do as practice. So I personally recommend doing that over the next couple of days, is adding in the case for CD and adding the case for investment. What we're going to do on Thursday, however, is we're going to take the bank account system and we're going to convert the bank account class into an abstract class so that all of these now work from the abstract class of bank account. Instead of using an interface, you can see how that changes our system. how does that change the system, and how does an abstract class work different from an interface? So we'll see the difference, and we will hopefully understand why this is actually an abstract class, not an interface, and why this is an interface and not an abstract class. And so we'll be doing that on Thursday and Monday. So your challenge for Thursday is technically the definite challenge is to try and convert this yourself. See if you can figure out how to do it. Take a stab at it. And the optional item and additional item is going to your bank class and add in the 2 other cases, CD investment and investment. See if you can add those to the system. Sound good?
Mhm.
Any questions? Awesome. I'll try to get this code up tonight, and this time I'll try to remember to actually add it to the playlist. So sorry about that. I know the video's up now, so I'll make sure to get that added to the playlist correctly. My mistake. Oh, and also that means actually cohort 8. I will also give you guys access to I'll give you the URL to the cohort 11 playlist, so you can watch those as well if you want to look at those. Anyway, I will see everyone on Thursday. Have a good night.
Bye.
See you Thursday.
Take care. Bye.
Peace.
Take it easy.